So last time I was able to implement two design patterns in this. The first one was strategy and the second one was observer. And we were able to run the observer pattern and check that so too. Uh, I'll I'll continue with this type of implementation, like asking GPT for some functions and then uh, you know enhancing it or updating it with a particular design pattern so that it works better. Uh, Unfortunately, our last chat lost, so I'll just give context to GPT again that what we were doing, and then we'll implement one or two design patterns more, and then that's it. Then we'll move ahead with our main project. So we'll close this task manager. Just quickly give it once. I am learning the challenges means you give me a feature, I implement it, and then you show me how that can be implemented better using solid and design design pattern. Now I have already done two challenges. One where we implemented strategy for our changes like uh, the channel of delivery, and we implemented observer pattern to observe. So I'll just keep that where implemented strategy for delivery of log mail to create task. Second, where implemented observer when a comment is added. Let's continue with this pattern. Give me third challenge. Learning in a variance. Yep. So we got a task recursion where implement recurring task. When a task is marked as completed, the system should check if it is a daily, weekly, or custom recurring task. If yeah, it should create the next instance based on its recurring system. So I do not actually. It's good to go in different design patterns, but I would like to take it on mainstream like strategy, observer, builder, factory. Those only. I guess they will help more because they are used even more common than these ones. So I'll just say are used. So we do use chain of responsibility principle. Uh, I I don't know if we use a command or decorator. I don't know. Maybe we do. Uh, all right, we'll go with the chain of responsibility one. Then we will maybe go for factory one, and then we will maybe go for. We'll see. So let's go for chain of responsibility. If there are additional businesses, then create notify. So by our normal we means what we can do. If we do not want to implement by any, you know, if we don't want to implement by any design patterns, we can just go ahead and do the cron job scheduler and check that if any task is recurring, and we can just record that. So similar to our earlier approach, this time too we can go ahead and do something like this. So we got task service, and then task service we run similar cron job, and in here we do recur tasks. So I don't know why it's written like this. Yeah. We do recur task, and we got the, so we do not want end time and start time or end time. We can just go ahead, pick up those tasks which are recurring, and then um, those which are recurring, and then for now we will just maybe keep a recurring type, two recurring types, and see. So just doing this, let's go into entity, task entity, and see. Here we can just check if it is recurring. So this is boolean, and we also say recurring type, so that either can be daily or let's say weekly. If task is weekly recurring, then we may recur it at the end of the week. So Sunday 12, Monday 12 a.m. Um, this and this, and in here, this one is like recur daily tasks maybe. We get all the tasks which we need to, so recur. I'll just write two functions, different for daily and weekly. So for daily tasks, we get the task, and if the task has, you know, status, so we have to handle the status changing gracefully. If the task status is in progress or to do, then we will make them pending according to GPT. Should create the next instance based on its recurrence strategy. There are additional bonus rules. So maybe we'll keep the earlier task as it is, but just create a new task with to do status. So Doesn't matter if the earlier task is done or not. We just grab all the tasks which has recurrence true and the recurrence type is daily. So recurrence not this. Uh, we grab all the tasks whose recurring is true and and the tasks recurring type is daily. We got all these tasks and so just to just to mm, distinguish between a recurred task, we can maybe name them as numbers. Um, we don't actually need to. That's fine. For now, we don't need to. We'll just create a new copy of it. That's it. So we got the recurring task, and we just create a new task based on it. So we can we can call this create though. This recurring type of this. So recurring type should also be undefined, allowed as undefined. Now it should not give error. There's still so instead of undefined, you can maybe just go for optional, and now it shouldn't. Yeah. So we can just give a task DTO, and in create task DTO as well, we can make these changes. So in create task DTO, we can go for recurring and yeah, recurring to boolean and recurring type to the same daily or weekly. So this works now, and we just create a new task with this function. So we go, we loop for each task in the recurring tasks, and in these we just create a new one. So create this dot create, and for create DTO we can go for all these things type, title, type, priority, or we can just give our task. That's it. Undefined is not unable to type boolean. Yeah, that's why I was saying it should be optional and sort of this. Now this works. We create for each task a new task, and that's it. This is how we get the recurrence. Now the um, user has multiple tasks, and we are recurring. So we can do similar thing for weekly as well. So we create another function. Um, weekly tasks. Um, recurring, schedule weekly. Uh, this should this should run on should run on end of each week. So day of week is I guess this one. If we go and make it 7, this should run on. I'll just check. So, expression. So, this only on Sunday. So at 12 a.m. on Sunday. So instead of that, we want it on Monday. So 1. Now this recurs the tasks on Monday. And yeah. Uh, yeah, I guess these are in observe. We were initializing these in command service. Okay. I'll just try to create a task here just to check. Uh, we go for post out and this. Let's just create a task. So task needs task create task DTO dispatch. This should be first task due date. So due date isn't necessary. We are just keeping then type. So type can be work. Perfect. Then we need priority. Priority is high. Recurring. So we need recurring true and recurring type to be daily. So daily recurring type. Done. We should be able to create this. Let's see. Yeah, task added. Let's just get all the tasks. Sure. Got the task. We have written who and everything. Uh, Now we cannot check actually. It works on 12 a.m. Right now it's 1 a.m. So we are the time is ahead. we can just show the GPT our implementation and ask for improvements. I don't want to waste too much time on um, coding. Instead, I want to improve these styles. So this is how I implement it and task.service.ts. Um, so this is true. How we have hard coded this, we are not even taking. But if we observe this, just for the simple without any pattern and all, we either we can pass pass the recurring type. So let's say we have to recur for daily, or even after that we have to write a particular separate functions just to. Oh, so I give different, I guess, due date. Yeah, different one works. Um, create a recurrence handler. So I do not think it used any design pattern here. Though it did implemented it quite well. Like it uh, used this recurrence handler, which handles the recurrence set next and handle. I don't know what set next means. Let's see. So daily recurrence handler handles set next is you give an handler to it, and this okay, this sets what should be the handler for the next recurrence, I guess. Mm, But then let you pass a request along a chain of handlers. Each handler will decide, is this task for me? If yes, handle it, else pass it to the next one. Oh, concrete handlers. Okay. We actually, what we do is we do chain dot handle, and then in this chain, we check. So here it says daily. Uh, if the daily, if it's a daily handler, so let's say we met the situation where uh, it is a daily handler, we are just setting the next ones. So we are making a chain that if we check for daily, and then if daily executes, then it's all right. Otherwise we go for its next, which is weekly. If weekly executes, then we stop there or we go ahead. So this is how we are building a chain here. Okay. I I do not know if we will be able to use it much, but seems like a good practice to follow. I'll just write it quickly. So we go for an interface. I have written everything here only, so I'll be writing this as well. We, we need a recurrence handler. So let's go. Recurrence, recurrence handler not es. I guess works. Maybe dot handler. Yeah. And I'll just check spelling once. Yeah. So we have the function which we want to call, and then whatever we want to call next. So in this interface, we recurrence handler in this the function which is set next, which is again an handler of type recurrence handler and handle. This should get a task of type task. That's it. Um, what it returns is nothing, I guess. Okay, it returns a recurrence handler, but this one returns nothing. And I was just checking why this returns recurrence handler. Uh, it doesn't seem like there is any particular use case. It's just recur doing that. So now we have a recurrence handler. We can make a daily task handler and a weekly task handler. Even though we are making separate classes for each. Oh shit! What did I write? Thank you. So even though we are making, did I just duplicate it? No. Duplicated multiple classes, but still it's better because we have to execute one of them each time. So daily task teams and similarly weekly task teams. So we'll go for daily one. Where is daily? This is class daily task handler which implements our recurrence handler. Okay, it's class. I didn't say it. Recurrence. I haven't exported it. Recurrence handler. It should implement its quick fix implement, and this should just set. So for next, uh, with set next we can just set the next for. So we should have either we should have property of next handler. How does it get that? Let's say we have our next handler of type recurrence handler, and what we are doing is we are just setting this dot next handler is equals to our handler, and we are returning this does the job uh, for handle recurrence. For daily, we can just go ahead here and do this. Just copy it and paste it. And mm, so either way, how do we do this? First of all, copy drawing thing. Have to copy this. But we cannot declare the can be. Now we cannot. How does when handle it just checks and does the handling, and we call it every day. We call it every day, and for weekly task handler this one works, but still we are recurring, we are calling weekly task handler every day. Even for weekly task, which should be required all week and once in a week. Doesn't it just breaks whatever was the idea because we just didn't want it to. Gypty just plays game with us, said that we do not even need it. Yeah, but we got the idea what chain of responsibility does. So let's say we want to handle something and it's of certain type, and we should only execute whatever the function is related with that certain type. We can just implement multiple handlers which has one handle function and one passing function. And in handle function, uh, if we do not match, if we do not execute the handle, we just pass it on to the handler, next handler. How it is doing, let's see. So if 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 this certain condition executes, then it's all right. Otherwise, we pass it to the next handler. We always check for the base condition here and then either execute or pass. This is the main focus of handler. We are able to do it. Let's just move on to maybe one more design pattern. So I'll just check what are a few famous patterns and then we might ask for them specifically. Go for the, we have abstract factory, adapter, and builder, then singleton. Like, so this is the chain of responsibility. It's not rated quite high. Iterator is definitely one pattern. Observer we got, strategy we got. So we can go for adapter, abstract factory, and builder. So let's just go for let's go for another challenge. A feature, key feature, an example of we go for adapter. Add external calendar sync. Allow users to sync their task with external calendars. Some user want to automatically sync their task due dates. So if let's say I want to sync my task to another third party calendar, there could be many of them. We should not create a concrete implementation, but just for the sake of learning purposes, I'll just write code. Uh, for this, I'll just oh, let's not give anything. It's anyways wrong, and this is not the use case of chain of responsibility. But let's see. So we had to implement external calendar sync. I'll just make I'll just make so when we do external calendar sync, let's say we have a Google Calendar and we call Google Calendars function, and in Google Calendars function, let's say we do an API call with our data so that it syncs on its end. We just mock the behavior. I'll just create a service named Google Calendar uh, mock something like that. So Google Calendar mock.ts. Now we got a Google Calendar mock service. We can go for a function which works like a sync function. So let's go for this class Google Calendar and doesn't implement anything. It has a function of sync cal and in sync cal it just takes the movie date that and I if I want to simulate a real it doesn't work like that, but let's say that we get a bunch of dates and just a title. So we just want to show on this date this title. So an array of syncing. Okay. I'll just write a type here. Type um, sync obj, which should be uh, let's just say sync, which should be an array of sync obj. So sync obj this and sync obj is is what it is. It has a title and yeah maybe title which is string and then date. So this should be date. Now this expect a sync of type. I should have given type capital. So sync and what it does it just saves. So it does nothing. Maybe just sync console sync with Google Calendar. Right, got this and table. Cannot make this injectable. So signature has no properties in common with section scope. Google Calendar has maybe just that I cannot make this injectable. It just doesn't come in providers. For, we just wanted to make use of it. Let's say in our task service we want to sync. So sync with Google. And when a user do this, we take all the tasks and we sync it with Google, whichever has due date. So once due date task this one filter task. So whichever task has due date, we get them and we sync them. So to sync them, we need to create an object for that class. We can do it here. Private, private. read only. Oh, because it's private read only. Um, yeah, Google Calendar export Google Calendar, and now I can use the sync. So for each task, so do task dot map for each task. We go ahead and we do, or we can just directly create an object for it. So let's say const sync tasks array. In here we just push sync task dot push an object with title as task dot name something title, and can push date. What we had here is date which is task dot due date. Done. This gives us of type sync object. And let's export this. Now sync object. Array of sync objects. I got all these which are in this refinement. This is not equal to undefined. Built undefined is not. Oh, sorry. We should do. Yeah, we are doing it only the tasks. Okay, we'll just ignore it for now, and yeah, we are syncing the sync tasks, and we do Google Calendar dot sync here, and we go for sync tasks. So yeah, and let's give this to GPT. Yes, and show it what we made. What it just gave the implementation completely different interfaces across models. If we go which is true, like this we had a different implement we had a particular implementation. We needed some type of object for um, Google Calendar, so we made that object. Let's say if we want to sync with um, you know Outlook now, then we have to make object for that, and that's not how it should work. Though it should, the caller function should be same, so that the upper level of code should not need to worry about how this particular function is implemented. We can just call like sync, and then should sync. So design a common calendar service. Yeah. So each pattern kind of works on interfaces, works on add event, remove event, and so for this thing, an adapter is nothing but just an extension of something. It's very straightforward to how interfaces work. Like this is what we do for interfaces. We implement the methods which are going to be implemented. We define the methods which are going to be implemented in a class. So according to right now, we do not have. Let's just see how the adapter works. For example, we'll see in TypeScript only. Maybe. Yes, and that, for example. So we got an adapter and adaptee or adapter extends target. We got a target. These are all the classes, and I can work just fine with the target object. The default targets behavior. The adapter class has a wide interface. I don't understand it. In target, the target defines the domain-specific interfaces where the client. Okay. The adapter contains some useful behavior, but its interface is incompatible with the existing client code. Needs some adaptation before the client code can use it. So, adapter makes the adaptee's interface compatible with the target's interface. We got an adaptee, and then we do this dot adaptee dot special request. And just the related to task manager works. Charging a phone with a US charger and a US charger works with two flat pins. You are in Europe, all sockets are round pins and 220 volts. You need an adapter to the US charger. Okay, so the the implementation is that the inner implementation still remains same, but to use it with better, we need an adapter. So we got an socket and we got a charger, but we we make a adapter to to use this charger basically to use this socket. So this adapter So instead of using the socket directly, we use the adapter with this. This program to 20 and then we need to create an adapter here. Animation. Your code which uses a custom logger interface, but your team decided to migrate to Winston. You don't want to change hundreds of logger.log calls in here, so you add that Winston to your custom. We have your system express this logger interface everywhere. Winston logger. So Winston logger implements logger. Okay, now use the without. Okay, understood. So instead of doing like we use a Winston logger here without even changing how this is using it. Quite unrelated to how our system works, but yeah, we can understand one or two more important ones. So we can go for an abstract factory and a builder as well. So let's go for builder first. Okay, now same for builder. Building plus HTTP request object to building maintain to build multiple different to accomplish the subject you are building class has a set method for every one and a build method. Okay. So instead of writing everything in uh, in an object, we and like that is a nested object. We just write everything in a single line with set method. Fairly easy to understand, fairly easy to use. This is pretty nice. And abstract factory. Things will be a component. Imagine you are building a design system like a component library that supports multiple themes. Each theme provides its own button. You want to create themes for component without it else everywhere. It works until you have timeless component platform. You got a button or input or whatever we have components, then create product implementation. So we got light button which does something, dark button, factory. So we have a UI component factory and we extend that with light theme factory and dark theme factory. Okay, this again is just hiding the implementation. So making a factory and that factory decides what needs to render. Basically, factory has uh, methods, the main methods, but uses a particular type. So if we want to implement an factory, we make a factory interface which should have those methods which we want in our different subtype of factories, and then we basically implement them. Though they have this just creates a lots and lots of interfaces and classes. Okay, now I do not want to extend this POC anymore, so we'll just stop here. We have looked at some Nest.js. I looked at few implementations of uh, design patterns, understood how these works. Let's just try to design maybe some use cases for our project, and then let's see what happens.